Welcome to the Ready Academy. Tools for teaching, tools for learning, tools for life. In this video book, we cover trigonometry. This content was produced with AI assistance and reviewed by a human instructor. We'll continue with the unit circle, trigonometry for any angle. Right triangles handle every acute angle from 0 degrees to 90 degrees, but the world has plenty of larger and smaller angles. A radar antenna sweeps through 360 degrees, a clock hand rotates well beyond a single revolution, and many physics problems involve negative angles. To make sense of sine of 150 degrees or cosine of negative 45 degrees, we need a definition of the trigonometric functions that does not depend on having a right triangle to draw. That definition is the unit circle. Sine and cosine as coordinates. The unit circle is the circle of radius 1 centered at the origin of a coordinate plane, with equation x squared plus y squared equals 1. Imagine a point starting at the coordinates 1, 0 and rotating counterclockwise around the unit circle. Let theta be the angle, measured in either degrees or radians, through which the point has rotated. At any moment, the point sits at some location xy on the circle. We define cosine and sine of theta to be those coordinates. Equation 10, cosine of theta equals x and sine of theta equals y. The cosine of an angle is the x coordinate of the corresponding point on the unit circle. The sine is the y coordinate. Animation 6. A unit circle in the coordinate plane. A radius arm begins at the positive x-axis and rotates counterclockwise, tracing the full circle. At every position, a dashed vertical segment drops from the tip of the arm to the x-axis. Its length is the sine of theta. A dashed horizontal segment runs from the origin to the foot of the vertical. Its length is the cosine of theta. As theta sweeps from 0 to 2 pi, the labels cosine theta and sine theta update continuously, showing how both functions are born from the single rotating arm. Figure 19. The unit circle in the coordinate plane, with a radius drawn from the origin to a point P at angle theta from the positive x-axis. The point P has coordinates cosine theta, sine theta. Its x-coordinate is the cosine of theta, and its y-coordinate is the sine of theta. As theta increases from 0 to 2 pi, P traces the entire circle counterclockwise once, giving sine and cosine a domain of all real numbers. This definition agrees with the right triangle definition for theta strictly between 0 and pi over 2, because the radius, its horizontal projection, and its vertical projection form a right triangle with hypotenuse 1. But the unit circle definition works for every real number theta, positive, negative, larger than 2 pi, anything. Two fundamental facts follow immediately from the coordinates xy lying on the circle with equation x squared plus y squared equals 1. First, substituting cosine theta for x and sine theta for y gives the Pythagorean identity. Equation 11. The Pythagorean identity, sine squared theta plus cosine squared theta equals 1. This holds for every angle theta. It is arguably the single most useful identity in trigonometry. Second, returning to the starting point after a full revolution means the functions repeat. Equation 12. The periodicity identities, sine of theta plus 2 pi equals sine of theta. Cosine of theta plus 2 pi equals cosine of theta. Both functions have period 2 pi, the mathematical fingerprint of everything that repeats. The other four trigonometric functions extend from sine and cosine. Tangent theta equals sine theta over cosine theta, whenever cosine theta is not 0, and similarly for cotangent, secant, and cosecant. Worked example, a point on the unit circle. A point on the unit circle has x coordinate -3/5 and lies in the second quadrant. Find cosine theta, sine theta, and tangent theta for the corresponding angle. By definition, the x-coordinate of the unit circle point is the cosine. Cosine of theta equals -3/5. To find sine of theta, apply the Pythagorean identity from equation 11. Sine squared theta equals 1 minus cosine squared theta, which is 1 minus 9/25, which equals 16/25. Taking the square root gives plus or minus 4/5. The point lies in quadrant 2, where the y-coordinate is positive, so we take the positive root. Therefore, sine of theta equals positive 4/5. Compute tangent as sine divided by cosine. Tangent of theta equals 4/5 divided by -3/5, which equals -4/3. So cosine theta equals -3/5, sine theta equals positive 4/5, and tangent theta equals -4/3. Sines in the 4 quadrants. The unit circle divides the plane into 4 quadrants, labeled 1 through 4 counterclockwise from the upper right. The signs of x and y depend on the quadrant, and therefore so do the signs of all 6 trigonometric functions. Animation 7. The unit circle divided into 4 quadrants. Each quadrant lights up in turn, displaying the sign pattern of its x and y coordinates. Quadrant 1, x positive, y positive. All 6 functions are positive. Quadrant 2, x negative, y positive. Only sine and cosecant are positive. Quadrant 3, both coordinates negative. Only tangent and cotangent are positive. Quadrant 4, x positive, y negative. Only cosine and secant are positive. Figure 20. The 4 quadrants, each labeled with the trigonometric functions that are positive in that region. The mnemonic "all students take calculus" captures the pattern. Reading counterclockwise from quadrant 1, all positive sine, tangent, cosine. The reciprocal functions follow the same sign as their parents. Try it. Signs of trig functions. Without a calculator, decide whether each of the following is positive or negative, and name the quadrant. Part A, sine of 200 degrees. Part B, cosine of 300 degrees. Part C, tangent of 100 degrees. Part D, sine of -40 degrees. Part E, cosine of -150 degrees. Pause the video now and give it a try. Reference angles. The reference angle is the practical tool that lets you compute the sine of 150 degrees or the cosine of 240 degrees using only what you know about acute angles. The reference angle of theta is the acute angle between the terminal side of theta and the x-axis. Reference angle formulas for 0 degrees to 360 degrees. In quadrant 1, the reference angle equals theta itself. In quadrant 2, the reference angle is 180 degrees minus theta. In quadrant 3, it is theta minus 180 degrees. And in quadrant 4, it is 360 degrees minus theta. The strategy. Compute the trig value for the reference angle, which is always acute, then attach the sign determined by the quadrant. Figure 21. Reference angles for 4 sample angles: 30, 150, 210, and 330 degrees, 1 in each quadrant. All 4 share the same reference angle of 30 degrees. The terminal sides fan out across all 4 quadrants, but the small acute angle each makes with the x-axis is identical, so the sine and cosine values differ only in sign. Worked example, using a reference angle. Find the exact value of sine of 210 degrees. Identify the quadrant. Since 210 lies between 180 and 270, the terminal side lies in quadrant 3. Compute the reference angle using the quadrant 3 formula. Reference angle equals 210 degrees minus 180 degrees, which equals 30 degrees. Evaluate sine at the reference angle using the known special triangle value. Sine of 30 degrees equals 1/2. In quadrant 3, the y-coordinate is negative, so sine is negative. Therefore, sine of 210 degrees equals negative sine of 30 degrees, which equals negative 1/2. The exact value is sine of 210 degrees equals negative 1/2. Worked example, a negative angle. Find the exact value of cosine of negative 5 pi over 4. A negative angle is measured clockwise. Adding 2 pi to negative 5 pi over 4 gives an equivalent positive angle. Negative 5 pi over 4 plus 2 pi equals negative 5 pi over 4 plus 8 pi over 4, which equals 3 pi over 4. The angle 3 pi over 4 lies in quadrant 2 between pi over 2 and pi. Apply the quadrant 2 reference angle formula. Pi minus 3 pi over 4 equals pi over 4. The reference angle is pi over 4, and the cosine of pi over 4 equals the square root of 2 over 2. In quadrant 2, the x-coordinate is negative, so cosine is negative. Therefore, cosine of negative 5 pi over 4 equals negative cosine of pi over 4, which equals negative square root of 2 over 2. The exact value is cosine of negative 5 pi over 4 equals negative square root of 2 over 2. Try it, reference angle practice. Find the exact value of each, showing the reference angle and sine reasoning. Part A, sine of 120 degrees. Part B, cosine of 225 degrees. Part C, tangent of 330 degrees. Part D, sine of 7 pi over 6. Part E, cosine of 11 pi over 3. Pause the video now and give it a try. The full unit circle. The values of sine theta and cosine theta for the most common angles can all be displayed on a single diagram. 16 standard angles are marked around the circle in both degree and radian form. Figure 22. The complete unit circle diagram. 16 common angles, 0 degrees, 30, 45, 60, 90, and their reflections in each quadrant are marked around the rim in both degrees and radians. At each angle, the exact cosine theta, sine theta coordinates are labeled. The same 5 values, 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1, reappear in different sign combinations all the way around the circle. A useful way to commit this diagram to memory: learn the first quadrant values, then apply reference angles and quadrant signs to extend to the rest. Animation 8. A radius arm sweeps counterclockwise around the unit circle, pausing at each of the 16 standard angles. At each pause, the exact cosine theta, sine theta coordinates appear beside the point, the x-coordinate in navy, the y-coordinate in amber. After completing the full circuit, all 16 coordinate pairs remain on screen simultaneously. The whole unit circle at a glance. Try it. Unit circle values from memory. Without looking at the unit circle diagram, Write down the exact coordinates cosine theta, sine theta for each angle. Theta equals 0 degrees, 90, 180, 270, 30, 150, 210, 330, 45, 135, 225, and 315 degrees. Pause the video now and give it a try. That wraps up the unit circle, trigonometry for any angle. Next up, Section 5, Graphs of the trigonometric functions. If you found this helpful, like and subscribe and support the channel.